Helicopter factories are usually huge factories employing around 4,000 to 7,000 people, building different kinds of helicopters. Those used by police, the Air Force, private helicopters, rescue helicopters and many other kinds of choppers. Today we shall see how helicopters are manufactured in factories. This is how the production of the helicopter starts. Helicopter parts are manufactured differently, in different sections, and then assembled all together. Therefore we shall review the manufacturing process part by part. The rotor blades. 50 employees can produce around 400 blades per year by hand. These can be 4 blades or 2 depending on the type. They are made to revolve at more than 380 rpms and have to withstand tensile forces of up to 20 tons. Rotor blade always have an average length of more than 5 meters and weighs around an average of more than 40 kilos. The blades are made by hand, using huge forms. The first layer is fiberglass, then comes 3 layers of carbon fiber and a resin matrix. The so-called blade root is that part of the blade that is later attached to the rotor head. This part must be extremely strong. Forces are at work here during flight, that is why the specialists who build them put on 24 individual layers of the carbon fiber material. They normally use especially long strands of glass fiber called roving. Roving as individual threads, lie side by side covered with resin. Roving are extremely strong in the direction of the tensile force. They can keep the entire rotor blade right where it's supposed to be. A single roving could easily be used to pull a large truck. The inside of the blade is filled with a light rigid foam core. The half of the rotor blade is put into a special presser, the upper half being already in the form. The 2 halves are pressed together with a pressure of 200 bar at 135 degrees Celsius. After 11 hours the process is finished and the carbon rotor blade is ready to go. However, only those blades are approved for flight operations that have gone through a series of quality control checkup including visual, hand and finally computed tomography scan can continue to the next step. If it does not meet the high demands it will be scrapped. The blades of the main are then taken for testing. At rotor test bench, the blades are brought into balance. When the blades have been set up they let them run for about 15 to 20 minutes and then look at the data. Good balancing blades are always noiseless. The rotor hubs. The rotor hubs are created in the metal cutting departments with high-tech milling machines. Shaped in forged titanium blanks with an accuracy of 1,000th of a millimeter. The hub has to be absolutely round, that's why it is given up to 10 days of rest in order to recover from the high tensile forces. The hub can weigh 150 kg or more. When finished, it's worth 25,000 euros. Later the blades are firmly fixed to the rotor hub. The main rotor has an average diameter of 10 meters and spins at a speed of more than 383 rpms. Extremely strong centrifugal forces tug at the star-shaped component. The frame. A computer-operated high-performance cutter cuts slices of carbon fiber and glass fiber sheets with millimeter precision. In a complicated process these materials are combined to create what is technically referred to as carbon composite. This ultralight and very strong material gives the helicopter excellent flight characteristics. A number of people work in the production of these carbon composite parts. The sticky material is applied to a large mold layer by layer. The material is carbon fiber fabric, individual fibers embedded in a resin matrix. Traditionally aircraft construction used aluminium. But today, the trend is going more and more towards using carbon fibers. Carbon is a very light material, and of course the resulting helicopter is also lighter, as a result it can stay in the air longer. A steel mold is used to create one of the doors of the helicopter. The doors are made completely out of the ultralight glass and carbon fiber material. First, sticky fiber material is put into the steel mold, the negative of the side door. The first layer of glass fiber is followed by 8 layers of carbon fiber fabric. In order to create the extremely strong carbon composite, the pockets of air have to be removed from in between the various layers. Pockets of air would make the material porous and unstable. A silicon cover is then put to create an airtight seal so that a vacuum can be created in the steel mold. Hoses are attached to which air extracted under the cover, and also the air between the glass and the carbon fiber layers. After vacuuming, a lid closes off the mold. It is then placed in a special oven, a so-called autoclave. In the autoclaves, the composite parts are subject to heat and pressure. A standard home pressure cooker works in the same principle as this autoclave. Inside the autoclave there is a pressure of 7 bar and a temperature of around 180 degrees Celsius. The side doors and other frame parts are subjected to these conditions for 10 hours. When finished, it is so light that you can pick up the side door with one finger. This shows how light carbon is compared to aluminium. Since the 1990s, helicopter companies have been using more and more composites instead of light metals like aluminium. Carbon is extremely flexible and stable, and above all, it's very light. A large part of the helicopter is made of composite materials. For example, the tail boom, the cabin frame, and the doors. These parts take a very large element of the helicopter, but when you consider all of them joined together, they only weigh 11 kilos. This is extremely unbelievable. Assembling. The main component of the helicopter are assembled together. On the roof of the helicopter, they install a firewall. One engine of a helicopter can heat up to 150 degrees Celsius, but this is not a problem for the firewall because titanium melts at 1668 degrees. The engines. On the roof of the helicopter, 1 to 4 turbine engines that drive the rotors are installed. Most helicopters have more than one engine, such that, even if one of the engine failed in mid-flight, the helicopter will have no trouble continuing on its way. Assembling the engines to the helicopter is something that is not easy. Despite the robust technology used, those assembling it have to be very careful. Slowly and carefully the cranes have to lift the average of 130 kilogram engine into the air with pinpoint precision. Then a heat-resistant covering made of composite material seals off the engine. Wiring. More than 50 employees have to be used to put in electric cables depending on the equipment of the helicopter. That alone can take up to 18 days. Several thousand meters of cable go into every helicopter, but the experts in the factory always keep a clear overview. Where the cables have to go is carefully calculated. Every gram at the wrong spot changes the center of gravity and thereby the flight behavior of the helicopter. The center of the complicated cabling is the main console in the cockpit, the monster of a task. Thousands of connectors and connections have to be correctly installed. These can go for up to 20 kilometers. Interior. Before putting anything in the interior, the helicopter has to be painted well. The interior are the last parts to be installed. It takes more than 10 days for the men to put in the interior paneling and to fit it to the customer's needs. The cables are covered and all seats installed according to customer's needs. Testing. After just 3 months, a brand new helicopter is ready to go on its first flight. All the helicopters that are built have to go for testing. First, an optical checkup, which is then followed by a so-called ground run. Before leaving the ground, all the instruments are checked very well. While the engines are running, the values shown in the displays have to meet very exact norms. Only once the helicopter is proven that it is functioning perfectly are the pilots allowed to take off. The test pilot flies a set protocol with mandatory maneuvers, hover forwards, sideways, rotation, around the vertical axis, and with the nose down. During these maneuvers, test flight engineer compares the data shown by the displays with the norm values in the protocol. The helicopter is now officially allowed to fly in public airspace.